again, those steps, so the steps that we had yesterday are going to be helpful for factoring any of these in any form that they have. Yes, sir. So we're going to look at some more here. These are going to be maybe considered a little bit more complex, but the steps don't change. The numbers do. Now, when we look at this here, what we want to see first, our first step in factoring is to see and determine, is there a greatest common factor between 8, 56, and 48? Well, there should be. So if we factor 8 out of 8x squared, we get x squared, yes? What is 8 out of 56? Yep. And if we want to check it, we can do 56 divided by 8. And I believe we should get 7, yes? And 48 divided by 8. 48 divided by 8 would be, huh? Then we would move on to step 2, which is 2 sets of parentheses. So we have 8 parentheses with our 3 spaces, and then with our 3 spaces. So that's step 2. So the first step was to find the greatest common factor, and here we had one. It was 8. We factored it out. We divided each term by 8. We pulled it out front. Then we did step 2, or 2 sets of parentheses with 3 spaces, and now the signs. So the sign of the constant term. The constant term. It's always based off the constant term. I know on the board I didn't write if negative, opposite, if the constant term is negative. If the constant term is negative, then it's opposite. If the constant term is positive, up here or here, the signs are the same and they match the sign of the middle term, which is negative. So both of these would be negative. Negative? Yeah. Then they would be opposite. So if the 6 is negative, then they would be opposite. And we'll look at one of those next. We might have to skip a few, but we'll look at a negative one here in a minute. Okay. Now, we need to find the factors of the first and third term. The factors of x squared are just x and x, because that's the only way we can factor x squared, because x times x would give us x squared. Now, the factors of 6 are 1 times 6 and 2 times 3. Which one do we want to try first? Let's focus up here. 1 and 6. And the last step is checking, so we would do outer 2 and middle 2. X times negative 6 will be negative 6x. Negative 1 times x is negative x. And negative 6x minus x. Negative 6x minus x would be negative 7x. Is that what we wanted? So this here is the correct answer. This is what we want. This is what we want. This is what we want to have, because this here is the correct answer. This is the answer that we need. Any questions on this here? So this here should be very similar to what we did yesterday, because again, we're doing the main same steps as we did yesterday. We're going to skip 3 of them because I want to look at this one. We'll go back to those other 3. But I want to look at this one here first. Because again, this has minus 5. The constant's negative 5, yes? So we're going to look at this one here. Now, is there a greatest common factor between these 3 terms? No, there's not a number that will divide into all three. So we move on from step 1 to step 2, which is our two sets of parentheses with three spaces. Two sets of parentheses with three spaces. Now, the sign of the constant term is what? Negative. So if the constant term is negative, the signs are opposite. So one of them would be positive, the other would be so I just pick one. One positive, one negative. They're opposite. So one's positive, one's negative. It doesn't matter how we set them up. We just set one positive, one to be positive, and one to be negative. Now, x squared is going to be x and x. X squared is going to be x and x. Now, what are the factors of 4? 1 and 4 and 2 times 2, because we have two factors. Factors of 5, 1 and 5. So I'm just going to put 1 and 5 down, because those are our two factors. Because that's the only set of factors for 1 and 5. Now for 4, do we want to use 1 and 4 or 2 and 2? 2 and 2. We'll have 2 and 2. And lastly, we need to check. 2x times negative 5 is negative 10x. 2 times negative 5 is negative 10. 1 times 2x, positive and positive would be plus 2x. Negative 10 plus 2 is negative 8x. Is that what we wanted? No. Here, flipping the 2's won't change much, will it? But if I flip 1 and 5, here the 5 is now positive, the 1 is now negative, yes? Would that change it? Yeah, so let's look at this one. 2x times negative 1 is negative 2x. Positive 5 times positive 2x is plus 10x. Negative 2 plus 10 is 8x. But what did that do? That just changed what? It changed it from negative to positive, yes? So that's one thing to pay attention to. So if you get the correct middle term but the wrong sign, if you get the correct middle term but the wrong sign, change the signs. Because that's essentially what we did here. We made the 5 positive and the 1 negative, yes? Now, it worked this way because, again, 2x and 2x, that doesn't change, right? Because those are the same no matter how we set it up. Now, when we hit other problems where we don't have 2x and 2x, you need to flip the sign. You need to flip the sign. Because if it gave us 8x and we needed negative 8x, if you flip the sign, it'll change the sign to the middle term. But here it didn't work. So we tried both cases, yes? So let's try 1 and 4. Let's do this setup here. So we multiply this across. X times negative 1 is negative x still, yes? Positive 5 times positive 4x is plus 20x. Negative x plus 20x is not negative, it's, oh, I wrote negative. It's just going to be 19x. It's positive, yes? So we'll switch the 5 and 1. So let's check this here. Because x times negative 5 will give us negative 5x. 1 times 4x is plus 4x. Gives us negative x, and that's what we wanted, yes? No, right? That's not the correct one. So here, kind of like I said a minute ago, when we have the correct, because again, 2x and 2x worked by flipping that because 2x and 2x are the same, yes? Here, 4x and 1 are not. So we wouldn't change I'm going to change the sign. Because really what we need to do is if we get the correct middle term but the wrong sign, we need to change the signs. When we get the correct middle term but the wrong sign, we need to change the signs. Because when we change the signs, x times positive 1 is just x. Negative 5 times positive 4x is going to be negative 20x, which will give us our negative 19x. So we were almost there with x plus 5 times 4x minus 1. We just needed to change the sign. We needed to change the sign. So if we get it the correct number but the wrong sign for the middle term, you need to flip the signs. You need to flip the signs. You need to flip the signs for that. Questions on this here? Okay. So let's go back to this one here, the second one. Let's go back to the second one. So looking at this here, 14x squared, 31x, and 15. Is there a greatest common factor between these three terms? No. So we'll start off with two sets of brackets with three spaces. Next, we would look at the sign. Well, the sign of the constant term is positive. So it would, both signs would be the same, and they match the sign of the middle term, which is positive. So we're positive and positive. We will still have x and x, yes? Because that's the only way we can multiply together to get x squared. Now we need to look at the factors of 14 and 15. Factors of 14 are 1 times 15 and 3 times 5. So for factors of 14, do we want to use 1 and 14 or 2 and 7? Huh? So 1 and 14. What about factors of 15? 1 and 15 or 3 and 5? And so lastly, we need to check. X times 5 is 3 times 14. 3 times. This is going to be 37x. That's way too big, isn't it? 42x. So it's even bigger. Because that'll give us 47x. Okay, so what can we switch? Well, I could switch the 1 and 14 or the 3 and 5. Either one of them would give me the same setup, yes? Because if I switch these, I'm going to be multiplying 14 and 5. Well, we saw 14 and 3 is way too big, isn't it?
So
14 and 5 is going to be huge.
So we could switch out the 1 and 14 with 2 and 7.
Okay. 2 and 7. Because most likely doing these here, 1 and 14, 1 and 15, might not work. Because if we end up multiplying 14 and 15, that's going to be huge. It's going to be bigger than it. And what's 15 plus 14? 29, because that's the other way it would be. And I can show you that here in a minute. Well, let's try this here. So 2x times 5 is 3, positive 3 times positive 7 is 10 plus 21 is? Is that what we wanted? Yes. Yep. Because when we factor a common factor out of the start, we factor it out of all three. We have to factor it out of all three. Any questions on this here? Question? So let's look at this one here. 2x squared minus 7x plus 5. So our first question, is there a greatest common factor between these three terms? Well, no. There's not a number that will go into 2, 7, and 5. So we need our two sets of parentheses with 3 spaces. 2 sets of parentheses with 3 spaces. So that's step 2. Step 3 is to find the sign. What is the sign of our constant term? Positive. So the signs are the same, and they match the sign of the middle term, which is negative. So they're both negative. The signs are the same, and they match the sign of the middle term. So they're both negative. That brings us to step 3, and that's the factors of the first and third term. Well, since we have x squared first, well, I know that there's going to be an x and an x. Factors of 2, factors of 5. So what would be our factors of 2? 1 and 2. Factors of 5. 1 and 5. Do we put 1 first or 5 first? 1 and 5. And then last but not least, we are going to distribute. We're going to distribute. X times negative 5 would be negative 1 times 2x is going to be negative 5x minus 2x is, and that's what we wanted. So hopefully you're starting to see here, the more of these that you do, the easier hopefully these are going to become. So hopefully you're starting to see the pattern of how these work, how these operate. Let's look at this one here. Let's look at this one here. So we did skip 1. That's fine. So looking at this one here, so we're looking at our 6x squared plus x minus 12. Is there a greatest common factor between all three terms? No, there's one between 6x squared and 12, but we can't factor it out because we have to factor it out of all three. So since there's no greatest common factor, we move on to step 2, which is our 2 sets of parentheses with 3 spaces. 2 sets of parentheses with 3 spaces. So that finishes step 2. Step 3 is to find the sign. So when we're trying to find the sign, we look at the sign of the constant term, and the constant term here is, the signs are opposite. So one's going to be positive, one's going to be negative. So that took care of step 3. Step 4 is the factors of the first and third term. Well, the first term is going to have x and x, because that's where x squared is. X squared is part of the first term, so we would put x and x. Now we need to find the factors of 6. So what are the factors of 6? Then we need to find the factors of 12. And, and that's it. We have 3 sets of terms. Yes? So for 6, do we want to use 2 and 3 or 1 and 6 first? Now how about 12? 1 and 12, 2 and 6, or 3 and 4? Three and 4. So I just picked 3 and 4 like this here because, again, the last thing we do is check. 2x times negative 4 is negative 8x. 3 times 3 is? And this equals positive x. Is that what we wanted? Hey, we got it on the first try. And that's it. That's all we have to do to factor these. I want to look at this here. You don't have to write this down. But remember what we said yesterday? If there wasn't a common factor to begin with, there can't be any in the sets of parentheses. Could I have put 2 and 3 and 1 and 12 together? Because if I set it up in either way, 2 and 12 have a common factor, yes? Yeah. So they can't go together. 3 and 12 have a common factor, yes? Yeah. So no matter how I set it up, 2x, 3x, no matter if I put 12 in this spot or this spot, they would have a common factor, yes? So seeing that there's no way for this to work. 2 and 6, it will kind of work for this. Actually, it won't. Because 3 and 2 don't have a common factor, but 6 and 2, so 6 can't go here because they have a common factor, correct? Can 6 go with 3? No, they don't have, they have common factors. And that's some of the ways we can look at this. Because of those common factors, it helps us eliminate possibilities from showing up. Okay. Let's look at this type here. And we'll look at a few of these here. And what you're going to notice with these here is that it's not going to change how we solve these. Step 1 is to find a greatest common factor. There is one here. There is a greatest common factor here. Well, when we look at this here, is there a number that goes into negative 4x, negative 8, and 5? There is one. There is one. You all know what it is. What one is it? It's not positive 1, it's negative 1. Because have we worked one where the first term was negative? No. And I'm going to avoid doing that because I'm going to factor out negative 1. Because it'd be 4x squared plus 8x, then what? Minus 5. We flip the signs inside. Now, the reason I do this, and the reason I do this step, bless you, is because I would rather have it look this way here than to have the factors of 4x squared be 1 positive, 1 negative. Because that's how we would have to work it. And it'd mess some things up. It would mess up especially the finding the sign step, because it wouldn't work as well this way. But if I factor that negative 1 out, now it's back to the way we've been working them, yes? So if a is negative, factor it out, factor out the negative from all 3 terms, and then we go back to normal. Well, as we said, there's no common factor. Now, we don't normally write 1 when we're multiplying. So instead of writing negative 1 each time, you can just write the negative. But make sure you hang on to this negative all the way down, okay? Because on the test, if it works out that it has this setup, and you lose that negative in the answer, I will deduct a point. Because without it, This function here is different than this one. We need the negative in the answer. It is part of the answer. Now we look at the sign. The constant term is negative, so the signs are opposite. It doesn't matter really if you do plus and minus or minus and plus. You can pick one, whatever fits your fancy. So, factors of the first term are both going to have x and x. Well, 4 is 2 times 2. Let's go on and pick one. What do we want? 1 and 4 or 2 and 2? 2 and 2. Let's do 2 and 2. What are the factors of 5? And now we check. 2x times negative 5 is negative 10x. Positive 1 times 2x is plus 2x. And what does that give us? Negative 8x, yes? Is that what we wanted? Is that what we wanted? Are we looking at the first one anymore? What did we do? We factored out a negative 1, yes? Whenever we factor something out, a greatest common factor, we're not looking at the start. Because what are we actually factoring? We're factoring this thing here. What's the value of x? Positive 8x, yes? We need to switch the signs. Because again, what do we have outside of these parentheses? We have a negative 1, yes? So when I multiply the whole thing out, it's all going to eventually switch, yes? So if I said this was negative and we switch it, it becomes positive, yes? What was the starting one? Negative, yes? So we need what's inside those parentheses to be positive, so that when we multiply back through by the negative that we factored out at the beginning, it becomes back negative. So when we change it, we get positive 10x minus 2x, which gives us our positive 8x that we wanted. And that's it. So does having a negative a value really change much? No. It really doesn't change anything at all. We just factor out the negative 1 and then work it the exact same way. Yeah. Let's do that. Let's see, say this here is negative 9k squared minus 3k plus 2. Is it any different? No, we just have what? Okay. So what would be our first step here? We need to factor out the negative 1. Oh, hold up. Not that yet. Got ahead of myself. Because we factor out the negative 1, which gives us 9k squared. The negative 3 becomes positive 3. The 2 becomes negative. Now, if you find yourself having a tendency to lose that negative as you're writing it down from step to step, write negative 1. Write negative 1 in there instead. Because it will help you remember that's a number there. There's a number there for that. Now we need to find the signs. The constant term is negative, so the signs are opposite. Let's switch it up. Let's do a negative and a positive. Just something a little different. Because it really doesn't matter how we set this up to begin with. Because again, we're always going to end up checking it in the end, yes? So k squared's first. K squared's part of the first term, and when we find the factors of it, they will have k and k. There'll be k and k. factors of 2 are 1 and 2. I mean, it's just one fat set of factors, so I'm just throwing it down. Now, 9, on the other hand, has more than 1. Factors of 9 are what? 1 times 9 and 3 times 3. So what do we want to try? 1 and 9 or 3 and 3?
3.
Last but not least, we check. 3k times 2 is 6k. Negative 1 times 3k is negative 3k. 6 minus 3 is 3, and we have k. Is that what we want, Ian? So that there's the correct answer. That there is the correct answer. I would be careful with this in big ideas, because if it sets it up as k, it's going to want the answer in k. If it sets it up with x, it's going to want it in terms of x. I'm not going to make a big deal, especially on the test, if it was this here and you gave me in terms of x, you said it was negative 3x minus 1 times 3x plus 2. I'm not going to, it's not going to bother me either way. But big ideas is going to make an issue with it. It's going to want it in terms of k. Any questions on this here? Questions on this here? All right. I feel like y'all got a good handle on this, yes? Any questions on anything we did here? All right, guys, so the homework assignment for this here is probably not posted yet. I will post it right now, and we are done